All right, with problem 28, we have this table above that defines an operation x, like multiplication, on the set s is equal to a comma b. Which of the following statements about this operation x or multiplication is true? It's neither associative nor commutative, associative but not commutative, commutative but not associative, or both associative and commutative. Well, how would we test this out? Commutative is just an operation between two operands. And so in this case, we always start from the row. So we have A times A, and that would equal B. And so I might write that like that, A times A equals B. And then I have A times B, and that's equal to A. And so I would write that as A times B is equal to A. Then I would go down to the second row, and I would do B times A, and well, B times A is equal to A. And then B times B, well, B times B is equal to A. So the only time we really have commutativity here is when we have A times B is equal to A and B times A is equal to A. For otherwise we have A times A is equal to B, B times B is equal to B. So we can say that, B times B is equal to A. So we can say that A times B is the same as B times A, and they're both A. And we can say that A times A is A times A, which is B. And B times B is the same as B times B, and that's equal to A. So it appears that the situation here is commutative. So right away we can get rid of answer A and answer B. Now how can we test associativity? Well, associativity really, unlike commutativity, which only uses two operands, associativity really needs three operands. And so if we were starting with A times A, well, we could have made that if we added another operand, then that would either be AAB or AAA. And with AAB, we could multiply the first two together, or we can multiply the last two together. In order for it to be associative, then for each of these cases, whether we multiply the first two together or the last two together first, then we should have the same answer. So what is AAB? Well, when we multiply AA together, we got B above. So since A times A is equal to B, then parentheses AA close parentheses B is the same as B times B, which above we're told is A. So let's multiply the AB together. Well, above we're told that AB is equal to A. And so A times parentheses AB is really the same as AA, which again above we're told is B. And so just this example shows us that A parentheses AAB is not the same as A parentheses AB, which we would need to show that something is associative. So this operation is going to be commutative but not associative. And so the answer is C. Now we just happen to get lucky, but the first pair that we tried seemed to work out okay. If we had tried the AAA, let's see what would have happened. Well, the AA is B, and we would have gotten B times A, which is A, and A times A, which is B, would have given us AB on the second one, which is also A. So that just goes to show that if we had chosen that one first, it might have appeared to be also commutative. Now, we can't say that it's commutative for sure until we have tested out every one of the possibilities. And so if there were 4 of the original possibilities, then to each of those we could add one more element, and 2 more elements, an A and a B at the end of each of those. So we would have had 8 different possibilities that we would have to try out. In each of those 8, we would have to try with the parentheses at the beginning, around the first 2 elements, or around the last 2 elements. And we would have had to show that they all would have to come out to be the same in order to show that it was associative. So I would imagine we would get more than one where it didn't work.